Hello and welcome everyone to today's episode. Today we are going to be covering the following topics. All the timestamps are in the description below. And I hope you enjoy today's episode. So let's get started on these topics. Let's continue to explore Linq methods. So here, as you can see, I'm using a where Linq method. This one returns IEnumerable, but still it's of type person, which is class that I have here. So as you can see, this is my class. It has the following properties: name, town, country. And you can see this is the list of that class, which is passed into this Linq method over here. So the question becomes is, what if I only want to select the name and the town and not the country? So I don't want the country. So there's another Linq method called select. So if I do that, now what you notice is something strange. And this is generating an error to say cannot implicitly convert to an anonymous type. So the person here cannot be converted. So what's actually happening here? When you select subproperties of a class, such as name and town, but not the country, you then change the structure of that object. So what you need to do is, rather than say it's a person class, you need to define another class that will be responsible for it. Now, a quick shorthand would be just use the var keyword and this would work. But notice that you are now getting a problem in here to say this is also not valid. So what you need to do is you need to use the var keyword here as well, and then your code works. But another way you could do this is, rather than using the var keyword, what you can do is you can declare another class called simple person. So we have person here, but now we have simple person. Notice simple person now only has two properties, name and town, and those are the two properties that we are selecting using the select Linq method. Now here, you notice that what you need to do is, rather than new with no class name, what you do is you just select the simple person class. And now notice that we are still getting slight errors. This is because it's expecting the attributes of your new simple person class to be equal to your existing person class. So you need to manually tell the compiler that this is what needs to happen. And now notice that you get the error to say it cannot convert new simple person to a person class. So what you need to do is you just need to change that to simple person, and down here you just need to change that to simple person. And notice how all the code now works. If I run this code, and as you can see, we get the output that we wanted here. So I just wanted to make you aware of what you can do with a select. You can select properties such as name and town from an existing class and then put them in a new class, and then your IEnumerable also change that to the new class name, and then for your loop to actually print out the properties. So rather than using the var keyword, you can be specific and convert into another class type. Why do we have to use var keyword here? Why can't we use the original class type we had here? So with Linq, when you do a select, you create a new object. The reason of creating a new object is because you are only selecting the few properties from the original object or class that you created. So as you can see here, we're only selecting name and town, whereas we also have country in the original. So with lambdas, you can't select a subset of the attributes without actually returning a new object. So if I try and remove the new keyword and just try and do this, you can see we get an error. But we can, for example, do this, which is we just return a single string. So here we're only returning one property, but that means the data type will be of string because we are only selecting the name property from our object. So as you can see, that's a name there. And if you look at the name in our class, you can see that it's string type. So, but you can't do this. You can't say, actually give me the country as well. But you can't do this. You can't add country in here with a comma because that is invalid syntax. Lambda here can only return a single object. So Lambda cannot do this. You cannot return two items with a Lambda like this because these would be two different objects. So what you need to do is you need to surround them with curly braces like this and add the keyword new, and that makes the syntax valid. So as you can see here, this is valid syntax now because you're only returning one object, which is an anonymous object. So that's why we don't know the type of this object because we have just specified new, but we don't know what that new is. So here, as you can see, we normally have syntax like this, new person, but in this instance, we have not specified anything here. So that is why you have to use the var keyword. keyword. And if I run this code and see what data type we get by using get type, so this is the filtered and it's the var keyword. If I run this over here, and as you can see, this is the data type that we get. C# compiler builds this data type internally for you. So that's why the new keyword here just returns an anonymous object that C# creates for you, and then returns that object for which it will have the properties that you had. So here I am looping through, and notice again the use of var keyword here because we don't know the data type. It is behind the scene a data type, but we don't know what it is. So that's why we use the var keyword, and C# compiler will in turn replace the var here with the type that it has created for you. So we previously talked about Linq methods such as select, return an anonymous object like this. So here, as you can see, we are using the new keyword and there is no class type defined for this. So what C# will do is it will create an object behind the scenes which will have the following two properties, and then we just use the var keyword here, and as you can see, I'm using it to loop through the filtered variable later on as well. So that's the filtered variable here, and I'm just using it here again. So the reason for using the var keyword is, of course, we don't know the data type, because normally you would have syntax like this, which is new and then a class type. But here you can see we're using the new keyword, but we are not specifying what type of object it is. So C# will create that for you. So if I just run this code, you can see the type of this object that it creates is actually this list where select iterator 2. But we didn't know this during code creation. That only gets created when it passes through the compiler. So that's why we use the var keyword. But here's the modified code, and notice this time I'm using a class type of simple person. So what does that simple person class actually contain? So let's have a look. So you can see simple person has just the name and the town, whereas our full class, which is the person class, has name, town, and country. So then we just assigned the properties from the existing class, which is the person class, name and town, to our new class, which has the properties name and town as well. And what that allows us to do is then use simple person here as the return type, and then we are able to, in our loop, rather than using the var keyword, are able to refer to the class type for the filtered variable over here. And as you can see, if I run this code over here and get the type this time, so let's run this and find out what type we get. And as you can see, we get a type of simple person, whereas previously we've got an anonymous type. So as you can see here, when I try and get the type of this, we get anonymous. But as you saw before, that we get simple person rather than anonymous, because we can use the simple person class over here. And we have, rather than just returning a new object like this, we can actually return a simple person class type and not have to use the var keyword in situations where we desire. Here is another interesting use of the select method in the Linq in C#. So here, as you can see, I am using the select method after the where method, but within the select method, you can see that the Lambda here operator is actually executing an inline function or an expression. So here, this inline function, we can see is actually writing a debug message to the console, and then it is returning P. P is the original object, which is the person object. So as you can see, this has our person within here, and we've got the following people in our list. And what we are doing here is we are debugging or doing a write line. Now this could be, you could write a debug log to a file, but in this instance, we are writing it to the console and then passing that person object back for other methods to execute. So here, a transformation is being applied to change that to uppercase, and then finally we are converting that to a list. So when I run this code here, what you will get is the output that looks something like this, which is you've got the debug line being printed here, and then within the final transformation, you're just getting the output. So rather than writing an inline function like this, what you can do is you can instead write the debug person function separately and then call that function as part of the select. Notice that the syntax is pretty much the same. You're still retaining the person object being passed in, and you're just returning it. You're doing your debugging activity here, and then this pretty much makes the code neater and easier to read, and then you're carrying out your transformation. Now notice the difference between the inline function here and the actual function is any different other than you're specifying that you're passing in a person here, while with the inline function you do not have to state that because the Lambda operator here automatically does that for you. you. And notice here, when we pass this function here, you do not actually have to specify the argument into this function. They will be assumed. And it is a very interesting use of the select method within Linq in C#. Yet a really important difference to understand with Lambda operators and passing two parameters. So the select method is an overloaded method. What I mean by that is there are two parameters available that you can pass into this Lambda operator. One, of course, is the object itself. So in this instance, you can see key comes from the p pool. So that's one of the parameters you can pass. And you can see the syntax is quite simple. But if you also want to pass in the index, so because this is a list and you want to pass in at which position, for example, James, Victoria, Mark, or Taylor are at, then you need another parameter. But as you can see, the problem with this one is it's only passing in the individual person over here. So for example, it'll just pass in James, but it won't pass in necessarily in which position within the list James sits. So the select method has an overloaded method. So if we go here, you can see that this is how you would do it, which is you're passing it a person as before, and then you're also passing an index. This is separated by a comma, and you can see here that we have these two parentheses around this as well. And then the Lambda operator appears. So you can see the difference here because you're only passing in a single object. You do not need any parentheses or commas. You just then add in your Lambda operator. But if you want to pass in two arguments or parameters, then what you need to do is use a comma over here and also the parentheses. And then within here, you can see you can use the index and also the p object. You can also do the same. So this was the inline function as you saw. So we've got the inline function. But what you can do is when you have a situation where you're actually calling a standalone function like debug person over here, which is again as part of the select method, and this is the debug person, and you can see it can only take the minute a single object of a person. You don't even have to specify a parameter here for this function to work. So you don't have to specify that you're passing in a p person object. So how that would work here is in the same method. So again, you can see the two parentheses here, and you can see we are passing in p and I, and then you can see when we call the debug function, we actually then specify p and I over here, and then these get passed over here because that's the function's signature over here, and then you can use the index and also the p object. So I just wanted to demonstrate to you that you can all pass in a single object like the p, and it gets used automatically within here, so you don't even have to specify it. And similar in fashion, if you're doing inline, you just declare p and then the Lambda operator. But while if you want to pass in multiple parameters, you must use this style syntax over here and then call the function like this. Or if you're doing inline, then of course you've got your Lambda operator here, but then you've got your parentheses here, and then you're passing in the p and also the index. Now notice here I've called it index here, but you can call it whatever you want. And you can see here in this instance I have actually called it I, and it doesn't really matter because the C# compiler is clever enough to detect that p actually refers to the person and index is the second parameter here because that's what the signature of the method is. So the second argument or parameter here is always the index. So it doesn't really matter what you call it, it will automatically be an integer index value. That's why we have declared int here. Here is another important thing with the select method that you can use with Linq. So here you can see that the subfunction being executed here. So this is an inline function as part of this select method. And you can see the Lambda operator here. And after the Lambda operator, we've got the curly braces, which specify our function. So everything within these curly braces is our function. What we're doing is we're just printing a debug line and it returns the p object. What is the p object? It basically is a person object that we have here. So we've got James, Victoria, Mark, Taylor. So this select is being applied to all of them. So when we get this back here, this is then passed on to the next chained select method as part of Linq. And then you can see here we are doing the transformation, but we're also printing the type of p variable that we have. So here this one returns the transformation, which is it changes, this selects the name and changes that to uppercase, and then it changes it to a list here. So you can see an important thing going on here, which is when it does p.name.to upper, it will actually just return a string. So we at this point no longer have the original person object after this line is executed. To the next line, toList actually just is using only the name property and changing that to uppercase, and the age bit here is completely ignored. So here this is no longer the case now, included in the new object that is being generated. So if I run this code, what you can see is, so you can see in the final result we do have James here, we do have Mark here changed to an uppercase lettering. And what is important is you can see I have done a debug line just before this return line, which changes the type, and you can see the type is a person for Mark, and you can see for in a step further above, change the person object p here to a new object. So we can see I've commented out these lines, but if I remove the p there, now remember at this point we've got the person, but if I now activate this line, and you can see we're creating a new object and we are still transferring the two properties. So these two properties are still valid and can be used, for example, here to change name to upper. But what data type would we get? Previously, we have gotten person. So if I run this code here now, what you will actually get is an anonymous type here. So you can see we've got anonymous type for Mark and also for James. You can see James is here and you can see we've got anonymous type. So what we've learned here is as part of the select method, you can actually using the Lambda operator and an inline function or an anonymous function that doesn't really have a name, and you can return a new type by just using the new keyword without specifying its class, and it will give you an anonymous type. And then you can use that as long as the original property that is used later on is still valid, like in this case name is still valid, then your code will continue to work, but it changes the data type from the original person to an anonymous type over here. In some instances, you can see here the key.name to upper changes that even further to just hold the name string only, so it even ignores the age at this point. So this is where we are transforming the object that was originally a person class here, and we are changing that to a new anonymous, and then later on we are changing it once again just to a string object, and then that gets changed into a list. So this shows you how Linq can be used to manipulate the data type of an object and how it changes throughout the different transformations that you apply, such as here, or here, and here. Let's understand the GroupBy Linq method. So here I have a class which you can see is called student. It has a name and the class that the student is in. Then I am creating a list of students. So this variable here will hold a list of students, and I have the following students: Sally in math, Sarah in science, John in math, Zara in science, and Tom in history. So you can see I have 1, 2, 3, 4, 5 students. So what I want to do is I want to group all the math students together, all the science students together, and all the history students together. So a bit like the SQL method of GroupBy, what you need to do is declare another variable called group. This will hold your group of students, and then using Lambda operator here, you need to use the class. So the class here is the student's class. So that's the variable. In this instance, it's a string, but can be an integer too, or any other value that you want. So it will group it by this value of class, which is maths, science, or history. Then what it's going to do is any students, first it will go through, for example, math, and then it will look for another student who is in math and then add them together. And I won't necessarily do it in that order. So it will do it as it goes through the list of items. So it will create a subgroup over here for math, and then the next item is looked at, and if it is math, then it will add it to the same group. Otherwise, it will create a new group for science, and then because math already exists here, it will add this one done to the math group, and then science, because they already exist, it'll add it to science. Because history, the first time it's seen it, it will create a new group for it. So you can see that's where the groups will be stored. So then when you loop through the groups here, what you want to do is you want to show the key of the group. So what is the key of the group? It is basically the class type. So think of this as a dictionary. So you have key and value pairs. So the key will be the class. So that would be math, science, history. That would be your key. And the values would be the individual students under those groups. So once you have that, then you're going to loop through the students. So here we are going to loop through each student and print out the group key, which would be the class, and then the student name. So the student object over here is still accessible within the group and the group by. If I run this again, you can see a bit of pattern going on, which is under the math class, you've got Charlie and John, and then under the science class, you have Sarah and Zara, and under history, you have Tom. So this is how you work with the group by in C# and the Linq feature within C#. It is really important to understand theory behind things. So let's have a look at the theory behind the group by and how it actually works, and why do we use this var data type, and what data type do we actually get. So let's try and answer some of these questions. So as you can see here, what I'm doing is I am using the S class here, which is the class variable there, and I'm grouping it by that. But what data type would we get out here? So here I've got a right line that basically pulls the grouped variable, which is this one over here. We just get its type. And then later on, so that's the grouping, we then try and get the individual group here. So what is the data type of that? And then within the individual group, we then understand what is the data type here, because again, we're using the var keyword. So I'm trying to now get a student and see what data type that actually is. So if I run this code here, so as you can see, I've got the output output here. So let's examine this over here. So the very first time we are getting the data type here. So this is the grouped variable. So this is now applying the GroupBy, and we want to see what data type we get. So if we have a look at our output here, and you can see the overall type over here. So that's the overall type. We are getting the GroupBy iterator and enumerable iterator as well. And this is the student class, and this is the string. So why are we getting string and student over here? This is because our original class here is student, and that represents the objects which we are grouping. And then the string here actually represents the class. So why does it represent that class? Is because we are using the subjects over here. So history, math, science, these are just strings, and that's what we are grouping by. And that's why we get system.string here and student class type there. And then if we have a look at the next one, which is the individual group. So now if I scroll down, you can see this is now we are within here, and we are looping through the individual groups and getting its type. And you can see the next one is individual group type. We are actually getting a grouping type, and that again still holds the string as the key. So that's a class of a student and the student itself. So here that's again class, which is history, science, math. That's what is being stored within here, which is the key, and the values are actually just student. And then if we have a look at the last one, which is each item. So now we are looping through the group, and you can see that for that data type, it's actually student. So this is the original class that we have. So even though we are using the var keyword, the original class type, which is student, gets passed around in some sort of fashion behind the scenes. These data types, we do not need to worry about enumerable GroupBy iterator, because the C# compiler takes care of that for us. So I just wanted to run that by you, that behind the scenes, actually, you can see student and the key which we are using. That's the key, GroupBy key. So those are being passed around. How do you do counts and averages using Linq? So let's have a look at this code where we have students over here. So we got Ali, Sarah, John, Zara, Tom. And what we want is for their classes, so math, science, and history, we want to work out what is the total number of students in, for example, math, total number in history, total number in science, and also work out the average mark for them. So this is quite easy to do by using Linq. So what we first want to do is we want to group the items by class. So just imagine in Excel, we are trying to pivot and group the items by the class here, which is math, science, and history. Once we have that, then what we want to do is using the select method, we pass whatever we had out of the previous GroupBy method. So we want to pass this into the next one, which is pass into this Lambda operator. And then we are creating an anonymous object. The reason it's anonymous is because it's not based on a class type. Instead, we are defining the properties within here. So you can see class name, we are saying is g.key. So this g.key is basically referring to the key that we have. So for example, here is the class, that's what we're grouping it by. So this becomes the key. So history, science, and math become the key in this instance. Then for each key, whether it be history, science, or math, we want to do a count on the same variable that we got here, which is the group variable. And then we also want to do average. But for average, we want to define what should be done or calculated as the average or which column. So what we are doing is we are selecting the individual student within the specific group, so math, science, and history, and then we are taking the marks column in that specific group and working out what the average score is across that specific group of class. So this is going to generate a new class object for you, and then what we'll do is we'll simply loop through that group and the results that we have and print out the class name, which we defined here, the student count, which we defined here, and the average marks, which we defined here. So if I run this code here, and you can see that we've got our math class here, and we've got a count of 2 and average mark, and same with history, since it only has one student in it, so the only score we had was 88, and that's the score over here. So the average is also 88 because there is only one student. So I hope this makes sense. So essentially, to get a count, you can use the anonymous object here using the new keyword, define what you want. So we want the class name to appear, and then we want the student count and the average marks as well. And then we can loop through the results. So previously, I have talked about using the select statement here to create a new object so you can get count of items. But there is an easier way to do this. So rather than creating a new object like this is an anonymous object. What you can do is you can do your GroupBy here. So the class here is the class of which the students belong to. So math, science, and history. And once this is grouped, so here that's the class. So once that is grouped, you can just loop through that using for each. And for each group, you can get its key. What is the key? So the key is the class that the students belong to. So math, science, and history. And then you can do the count function here, and you can also do the average. Now the average function actually takes a lambda expression. So here using the lambda operator, you're saying take the marks column because that's the one we want to select to work out the average. So here you can see the other way is we are creating an anonymous object using the select method, and then we are getting the key, the count, and the average mark. You can see the syntax is pretty much the same as you see over here. So this syntax is very similar to what you get here, here, and here. This is, while here, this involves creating an anonymous object using the select method. I think my preferred way is using the anonymous method way, but again, there are instances where you can use this technique. So if I run this program, you can see the output that we get. We get the class, the math, and then we've got the count and the average mark, and then class science over here and the average mark. And finally, we get the history class, and it's only got one student, so that's 1, and the average mark is 88 there because we only have Tom who is doing history and his marks are 88. So yeah, it's just if you're getting started with Linq, and this is one of the easiest that you can understand, while creating anonymous object may seem unfamiliar territory.